Hi, my name is Alyssa Guzman, and I'm going to walk you through a greenhouse effect experiment I conducted earlier today and the results of that experiment and the implications of the results. So, when I was little, my grandparents had a greenhouse and they were able to grow a variety of plants in there despite the varying temperatures from season to season and day to night in Colorado because that glass building traps the sun's rays and keeps the heat in, keeping that building warm. Similarly, according to HOL Science, greenhouse gases in the atmosphere, like water vapor, carbon dioxide, methane, nitrous oxide, and CFCs, trap infrared radiation from the sun, maintaining a livable temperature here on the Earth's surface. So, I conducted an experiment measuring the heat absorption of a glass jar. It was this one from a 60-watt light bulb in this lamp right here over 20 minutes. And for the first time, my jar was filled with carbon dioxide, and the second time it was filled with fresh air. And the Earth's atmosphere is composed of different layers. So while this experiment is not an exact replica of our atmosphere, because it didn't have the same proportions of greenhouse gases, it is an adequate model. Because according to the Module 3 interactive lecture this week, it tells us carbon dioxide measured in parts per million has increased significantly over the past half a century and continues to increase. So, correspondingly, this experiment is an adequate model because it illustrates the impact of increased CO2 on heat absorption. In fact, Benestad explains infrared radiation is currently diverted downwards towards the Earth instead of escaping up through the atmosphere because of the increased greenhouse gases in our atmosphere. And did you know all greenhouse gases are not equally effective at trapping heat? In fact, Module 3 explains methane traps heat at a rate 20 to 30 times greater, but it's not as well known as carbon dioxide because methane only lasts in the atmosphere for like 100 years and it only comprises 10% of US emissions. Similarly, the EPA suggests nitrous oxide absorbs heat at a rate 300 times greater than carbon dioxide, but it only comprises 6% of US emissions and lasts in the atmosphere for approximately 114 years. So, carbon dioxide is much more well known because there's so much CO2 in our atmosphere. So, I chose to conduct this experiment in my kitchen and I marked the 7 centimeter difference from my jar to my lamp in two different places because I didn't want the heat from my first experiment to impact my second experiment if it was absorbed by the counter. And I started by recording the ambient air temperature in both locations. So the first location was 22.5 degrees Celsius, and the second location was 22.3 degrees Celsius. Um, and then I created carbon dioxide in a 20-ounce bottle by combining vinegar and baking soda. And then I transferred that gas into my jar using tubing and then sealed the jar with plastic wrap. And while the carbon dioxide was settling in my jar for approximately 11 minutes, I went ahead and created a hypothesis based on what I know about the greenhouse effect. And I thought the jar with CO2 would trap more heat, resulting in higher temperatures. So, again, after the CO2 settled in my jar for about 11 minutes, I took a thermometer like this and stuck it through the plastic wrap. And I actually had to hold it because I didn't want it to go all the way down and touch that. So I had to hold it the whole time, which was kind of annoying. And maybe I would have used a bigger jar if I thought about it. But for the first 30 seconds, I recorded the temperature. I'm sorry, for the first 10 minutes, I recorded the temperature every 30 seconds. And for the last 10 minutes, I recorded the temperature every minute. And my observations matched my predictions. So if you can see the data I collected in this graph here, the blue line represents my jar with carbon dioxide in it. And it started down at 22 degrees Celsius. And then after 20 minutes, it moved up to 42.6 degrees Celsius. And conversely, my jar filled with fresh air started down at 22.5 degrees Celsius, but didn't move nearly as high. After 20 minutes, it was only at 36.4 degrees Celsius. So again, we only see a small temperature difference in the fresh air jar and not the mostly CO2 jar because the prominent role of CO2 in trapping heat. And I recognize that properties of my jar, such as the size or shape, could have altered my results. For example, I mentioned using a larger jar, and that would have given the CO2 more space to occupy. And I don't know how that would have impacted my results because we could use a jar anywhere from 500 milliliters to 1,000 milliliters for the experiment. Additionally, while I worked hard to eliminate error, for example, I removed hot and cold beverages from my workspace, and I used those 2 test locations I talked about earlier. The environment in my kitchen is clearly not as controlled as a lab, and all sources of error can't be eliminated realistically. Still, I did take those steps I mentioned. I put a rubber band on my glass to make sure the plastic wrap was tightly over the jar. And I ensured my first jar did have carbon dioxide because at the very end, I lit a match. And as soon as it touched the top of that jar, it went out. Whereas my second jar full of fresh air, when I dropped that match in there, it reached the bottom and it continued to burn. So I was really thankful that my first jar did have the CO2 in there and I didn't have to conduct that part over again. Um, Obviously, despite these preceding limitations I just mentioned, this experiment clearly illustrates the impact CO2 has on trapping heat and subsequently can help illustrate the impact of greenhouse gases on global climate change.